Now that we read our Vermilion River background information, let's do a little bit of consolidating of the information and how each of those topics, transparency, stream flow, and dissolved oxygen, how each one affects the water quality of the Vermilion River. So big picture, what we're thinking about for each one of these pieces of data is what first can cause an increase or a decrease in the data. So what will make more DO or less transparency? And then also, are those features natural or are they man-made? And as we think about those things that are increasing and decreasing it, we want to know then, well, what does that do to the health of the river and the fish and the plants that live within? Is that a negative impact or a positive impact? So factor what makes it go up or down, and how does that affect the river's health? So the first measurement we took when we got there was the river's transparency. We scooped that bucket of water, we filled up our transparency tube, and we measured how clear the water is. So transparency is looking at a measure of clarity or clearness of the water, and we of course are measuring that in centimeters. So a little visual on the side here is showing us the clearer the water, the deeper I can see, or the higher the transparency, and then the dirtier the water, the less I can see, or the lower the transparency. The transparency or water clarity of the river can be affected by many different things. We have a short list here to look at to see what factors influence transparency and how do they influence. So our first one here is rain or runoff. So rain, of course, is a natural factor. Runoff can be partly natural, partly man-made, but both cause sediment to increase in the water, causing a decrease in transparency. So we can kind of see that in this picture here with the flow from the rain that's happening. It's bringing more and more sediment into the water, kind of kicking it up, stirring it up, and causing that transparency to go down. Construction, like road construction or digging into the earth, is going to create more loose dirt, which can be carried in by rain or runoff, so that will be a decrease. Same with agriculture, which is farming. We also are creating more loose dirt as we plant the plants, drive the tractors across the fields, till the ground, things like that. So more loose dirt means more possibility of it getting in the water, therefore lower transparency. Drought is the only one on our list here that causes an increase. The drought is basically doing the opposite of the rain and runoff. It is not disturbing the sediment because there's no water carrying it in or out. It's not mixing it up, so it keeps the water nice and clear for an increased transparency. With all those factors being able to change transparency, we see an impact to the river's health when transparency does go up or down. So what we notice is when the transparency decreases, there's definitely negative effects to the river. As the transparency decreases, it obviously gets cloudier because more sediment is mixing into the water, and that creates a problem for fish breathing. What we notice is it creates clogged fish gills. So essentially the same as we were breathing in smoky air, they're breathing in dirty water, causing an impact to their respiration. We also see a lower amount of sunlight levels, not only for fish, but also for plants. And so what this does is it lowers the health of the river when we have a lower transparency. We can also see that sediment smother eggs that have been laid or homes that have been created. If the water is really turbulent and over time it slows down, we can see that sediment cover up those places, again impacting the fish population and reproduction. So what do we want our transparency to be exactly? Well, we like to have it consistently be, at least for Vermilion River, at a measurement of 75 centimeters or above. So that means I can see through to a depth of at least 75 centimeters on a regular basis. If we do get a big storm, chances are that transparency will drop below 75 centimeters at one point in time, but that doesn't mean everything in the river is just automatically impacted or dying instantly. We want to kind of keep this on track for the long term. So I want to make sure it stays above that 75 long term. There may be a day or a week because of a storm where it drops, but overall I want it to stay above that 75 centimeters. Next data factor we're looking at here is stream flow, which is measuring the volume of water going through the river over time. So when we look at our unit, we have a measurement of both volume or amount of water and second, time. So we're looking at the amount of water going through the river in a certain spot over time. So just like we saw with transparency, there are factors that influence the stream flow of the Vermilion River, meaning things that make the amount of water increase and decrease. So when we think about the first two, they're kind of weather related, a drought versus rain. We're noticing that, of course, a drought means less water coming into the river, so therefore that would be a decrease in stream flow. Whereas rain and runoff would be more water coming in, that would be an increase. Seasons are a little bit tricky, summer versus spring. We actually would see plants absorb a little bit more water during the summer months because that's when they're doing the most photosynthesis, most growth, and so we see a small decrease in the stream flow at that time. Whereas the spring would have an increase due to the fact that snow melting or rain for those spring months starts to increase and roll into the river. The last one, human water use. We can use water for a variety of different things, for farming, just for daily use. So that would, of course, make the stream flow go down. So what do those changes mean for the river's health? Well, every increase or decrease has an impact on stream flow, and stream flow is kind of the trickiest one because we have a little bit of positive and negative with every change. So here we're going to look at what happens when the stream flow increases or becomes higher. Typically what we see with a higher level stream flow is more dissolved oxygen. And dissolved oxygen is, of course, measuring the amount of oxygen in the water, and so we like to see more dissolved oxygen for the animals in the river. And so that is, of course, a positive health impact. So higher stream flow means higher dissolved oxygen. However, higher stream flow also means that I have more erosion, which is what we see going on in this picture, where the land at the edge of the river is being eroded, broken down, and carried into the water. And so that means I'm getting a lower transparency during that time. And if we think all the way back to transparency, I know I want that to be a higher number. And so with all that sediment eroding into the water, transparency goes down, so does the health. So an increase in stream flow brings both positive and negative impacts to the river. So what do I want my stream flow to be at actually? Just like transparency, we had a certain number. We don't have a set standard for stream flow. Again, we just want to look at that stream flow for long-term trends. So we're going to keep an eye on it. We know during rain events, stream flow will increase. We know during droughts it will decrease, but we want to make sure that it bounces back. We want to make sure that any rain event or weather event happens and then the river comes back to balance. So we're keeping an eye on the long term when we're looking at stream flow. Our final factor here is dissolved oxygen. What we're looking at here is the amount of oxygen gas dissolved in the water, and that's measured in milligrams per liter. And we, of course, want to have dissolved oxygen in the water for those aquatic organisms. Again, what can make the dissolved oxygen either increase or decrease for those aquatic organisms? The two big factors are temperature and stream flow. What temperature does is limits the amount of dissolved oxygen that the water can hold. So when I have a warmer temperature water, I typically notice my dissolved oxygen can't be as high. It's a typically lower value than when that water is cooler. Colder water can hold more dissolved oxygen. So in the example of our brown trout of the Vermilion River, they like the water just a little bit colder because that means there'll be more dissolved oxygen. For stream flow, the higher the stream flow, the better the dissolved oxygen is. And I chose this picture because you could kind of see with a bigger stream flow, that water is kind of mixing up and moving around a little bit more, flowing over rapids. That's what we call aeration. And so by moving and bouncing around, it's grabbing a little bit more of the atmosphere, putting that oxygen into the water. So increasing the amount of DO with a higher flow. The lower the stream flow, the lower the dissolved oxygen, which we don't want. We could worry about the levels dipping too low. Finally, like we said, we want the oxygen to be higher than normal, or on average, I guess. So when we see a decrease in dissolved oxygen, we know that causes stress for fish. They're not as healthy. It can cause their death and their reproduction levels to go down. So we know that is definitely a negative health impact if the DO drops too low. Whereas if we see an increase, we know that can cause additional growth of the species. So we can see much more reproduction and thrive from those organisms. And so that is a positive health impact. So finally, we want to think about the standard for dissolved oxygen. And the Vermilion River does have a pretty set standard because there's such a big trout river. So the brown trout need at least 7 milligrams per liter or more, as always. And again, kind of thinking back to that idea that we talked about with transparency, if I have one day where it's below 7, of course all the fish are not going to die instantly. But if we keep an eye on it and it's consistently below 7, that's where we start to get concerned. So again, big picture, what we're thinking here is for each one of these factors, we want to know what are some things that cause increases and decreases within that factor, and what does that mean for the river's health? Are they good or bad for the river and the organisms that live in it?